Anyways, here we go. 6.5. Performing function operations. Okay, today is easy. Function operations are, things like, hey, I got this equation. I got this equation. What happens when you add them together? All right, so first, and stuff like that. So today is actually pretty easy. First things first, we got to talk about the notation. For addition, come on, fellas. Come on. Here you go. Addition. We've got, if you got something that looks like this, f plus g of x. I know, don't think too hard. That literally means take the f function and add it to the g function. Combine all the terms. Totally, it's exactly what that means. All right. If you got something that looks like this, f, like that, what do you think you're going to do to them?
Subtract.
Subtract them. I know.
I wonder why though.
I'm not really too sure. Anybody's guess. All right, what about this one? If you've got FG, yeah, it's f of x. You're right. It's also right by the multiplication sign times g of x. What? I'm lost. All right, last but not least, if you have f over g of x. What are you going to do to them? Divide them! Which one goes on top?
F.
F. Because it's on top over here. The F is on top here, so it goes up. If the G was on top, the G would be on top. Just like if I was subtracting the F, well, the F would go second. That sort of thing. Okay? So that's basically what all these are telling you to do. I know, you probably could have figured that out on your own, but for the few of us who don't, that's just what it is. All right, problem one. Problem one, what these are all going to do is they're going to give you a series of functions. So I got f of x is that and g of x is that. All right, and they're going to combine them in different ways. So like f of g of 4, f plus g of 4. So to start off, we're going to straight up add them together. Chaw. So take f, 3 squared of x. And then we're going to add g, negative 10 square root of x.
Oh, you just plug them in?
Yeah, you straight up grab the f function, grab the g function, put a plus sign between them, and combine these two things. All right, so they both square root of x, so how many square root of x's do you have?
2.
Negative 7. You just cursed on the video.
Alright.
It's okay, I don't care. All right, because it's, let me rewrite this a little bit. So negative 10 square root.
So you're not gonna put
I went to the 4.
the 4.
All right. No, this is the combined function. We'll get to the 4 in a second. It's like if they're asking for the function, this is the function. F plus g of x is that. You follow me? If they want to know, evaluate it 4, which is what the actual question asks. So f plus g of 4 is negative 7 on the square root of 4. So what's the square root of 4? 2. What's 2 times negative 7?
Negative 14.
Ta-da!
Wait, what?
I know you did.
How you get the negative 14 again?
What's the square root of 4?
2.
What's 2 times 7?
Negative 14.
There you go.
So what do you do with the other 4 then?
This one?
Yeah.
All right. Function notation dictates if it's f of g of x, that means you got a variable where x should be. If it's f of g of 4, that means, hey, stick a 4 where x is. Does that make sense? That's literally what this notation says. It says, hey, take this function and shove a 4 in it.
So what if you put a 4 instead of x?
Instead of an x, well, that's what you're supposed to do.
No, like on the push button.
Oh, that's fine too, but if it depends on what it's asking for. If it's asking for the equation, this is how you find the equation. If it's asking for f of 4, well...
So we have to do the next part, the second part?
Well, because it's saying f, it wants to know f plus g of 4, that's why we did the second part. Okay?
So we have to do the second
Yes. So here we go, letter B. There will be an answer, letter B. Okay, here we go. We got f minus 9, f minus g. So let's just start off by finding the equation. F of g of x. Oh my gosh. The f is still 3 root x. And it's negative 10 root x. But this time we are subtracting it.
So
It's really 3 root x. What? plus 10 root x, which is how many?
13
13 root x's. That would be the actual equation.
times, well, square root of 9.
Okay, so what they want you to do is take, you're right, f minus g of 9 would be 13 root 9, which what's the square root of 9? 3 times 13 is?
39, 40, 30.
Good.
I got it right.
Cool. Pretty straightforward. Today really is not get that difficult. Turn the page.
I'm going to get the stuff out.
All right. What? Oh, there you go. All right, so letter C. Take a second to do letter C. Do letter C, letter C. Did you actually get the equation correct?
Yes.
We good with that part? Just combine your terms. All right, so what are we plugging in for x?
-2.
Negative 2. And for all of your x's equals, I have an answer.
So that -2 on the end of the equation.
Oh,
5 minus 2, wouldn't it be 3?
yeah. No. Yes. Maybe. I mean, I have no idea what you're talking about. All right, here we go. So you're absolutely right. So that's 4 times -2 cubed minus 5 times -2 squared plus 4 times -2 plus 3. Okay, so what's 2 times 2 times 2?
-63.
Positive 8, but it's a negative, so it's -8. What's -8 times 4?
27.
Negative 32.
Good. What's -2? -32. Good. What is -2 times -2?
Four.
Positive 4. What's -4 times positive 4 times -5?
That's negative 20.
What's 4 times -2?
Negative 8.
And I'm pretty sure that equals -57. But somebody's taking the calculator and check it real quick.
It's -63.
-63? -32 minus 20, that's -52, minus 8, -60. -60 plus 3 should be -57.
Yeah.
Lost.
Negative 50 plus 3 is negative 50.
Is it?
Yes.
All right.
So what?
I don't know. I don't know. No. Here we go. All right. Cool. All right. Letter D. How is letter D different than letter C? You subtract. So let's do this one together real quick. We won't finish it all the way in, but we'll at least get it started. So it's the same thing to start with. 3x cubed minus 2x squared plus 5 minus x cubed minus 3x squared plus 4x minus 2. Just like that. Right?
Yes.
Say it, Maria.
Does the negative to the minus should be
Yes! We are subtracting the whole thing, not just the first term. Yes, this is the most missed piece of this entire section, is you forget to distribute your negative. Okay? So you're right, that negative has to apply to every single one of those. So that's 3x cubed.
plus 3x squared minus 4x minus 2x minus 2x.
Sweet! You don't change the first ones, you change the second ones. And honestly, like on your homework or even on your test, I really don't care if you just go ahead and switch all the signs right here on the right. Like just go ahead and write, oh, that means this is going to be a negative, that's going to be a positive, that's going to be a negative, that's going to be a positive. I'll know what you did. It makes sense. All right. What are you going to do now?
You combine like terms.
Combine like terms. So f minus g of x equals, how many x cubes do we have? 2x cubed. How many x squareds do we have?
Negative 1, right? Yeah.
-1 or +1?
Negative. Oh, wait, positive.
There you go. Plus x squared. How many x's do we have?
Only 4.
Only -4. Good. And that's still 4. And 5 plus 2 is still 7. So that would be the actual equation. And I trust that you can take a -2 and shove it in there.
Oh, yeah, of course.
Okay? Yeah. If you can't, we really need to talk.
Okay.
But whatever. All right? How are we doing this so far? Give me 5 and 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1, save me. Sweet. All right, problem number 2. This is where it really gets crazy, y'all. All right, yeah, whatever. All right, so for the following, uses f of x equals x squared, and g of x equals the square root of x. All right, now this is one of those times that I'm actually going to use, instead of the square root of x, I'm going to use x to the 1/2. And I'll show you why when we do this. So fg of x, what is it telling me to do to these two? Multiplying. So fg of x will equal x squared times the square root of x. Yeah, the problem with that is I can't really combine those as they are. But if I do like this, what do you do to two exponents when you're multiplying the same base?
Divide them.
No.
Add them.
You add them. So what is 2 plus 1/2?
2 and a half.
Let's leave it as a fraction.
2 and a half.
What's 4 plus 1?
You said the weird, you like the weird, you like the weird fractions.
I like the weird fractions.
Remember
I
that one
do.
time that we told you, like,
We-
you like,
You like mixed numbers?
yeah, the,
Do you know why I don't like mixed numbers? I did tell you? Okay, good. Yeah, I promise you, they're not improper.
How do you get 1 divided by,
That's-
5 divided by 2?
What's 2 plus 1/2? Ooh, why? I just erased all that.
2 plus,
What's 2 plus 1/2? That's 4 halves plus 1/2 is 5 halves. Just adding fractions is all we're doing. Yeah, it's 4th grade math. I know. It's okay.
what if you don't know 4th grade?
Well, then you're, as the French say, les screwed. All right. So here we go. If we've got go back to a pen. Fg of 9 to the 5 halves. Okay. Everybody remember, what does the bottom half of the fraction tell you to do?
Hey, I'm in the wrong side.
To what? Not square it, but you're writing it with your finger.
Cube it.
Rudy.
Square root it, exactly. You're right. Square root. So what's the square root of 9? 3. Oh, what's 3 to the 5th? It's big. I think it's 243, something like that.
243, yeah.
243. Okay.
Oh my god.
I'm brilliant. No, I've done it 4 times today. That's why I know that.
Okay.
Yeah, there is.
No, because like
If you turn it sideways, you get a scientific calculator.
Yeah.
it's not happening.
You have no idea how funny it is to watch you shake your phone like that. I'm sorry. All right, here we go. Letter B. Yes, sir. Sure. Letter B, we got f over g of 9. So which function goes on top, the f or the g?
The G. The F.
The f. So we got an x squared. And what goes on bottom?
X. X.
That's your g function?
X and 1/2.
X to the 1/2. Good. All right, so let's clean that up. X to the 1/2. So if I'm dividing my x's, what do you do to their exponents? You subtract them. So what is 2 minus 1/2?
1/2.
3 halves. So x equals 3. Oh, x to the 3 halves. All right, so here we go. We got f over g of 9. Of 9, yes, 9 to the 3 halves. So again, what is the square root of 9? 3. 3 to the 3rd power gives you 27. Yay! I can bring 3 of my friends. Cool?
So it's 9 times 9 times 9? Like 3 times
3 times 3 times 3. Yeah. You square root it and then you cube it. Take that answer and cube it. All right. So this was a little screwier because of the exponent rules. All right. Let's screw. Yeah. Try letter D real quick. Skip letter C and try letter D. When he comes back. Letter D. Letter D. Letter D.
You're not gonna come back.
God.
I got it wrong.
Shut up.
Look at that. But the answer is decimal 300.
No, it's 90.
Oh,
That's just plugging these answers in equation.
I was using the same one as the top.
Oh, were you really?
Yeah.
I'm sorry. It gave you new equations.
Yeah, I know this.
That's what it says.
I feel bad for who?
No, he just.
Because he said he had it right. He just wrote down the equation. No, just give him credit.
Oh, well, there you go. I'll give you 1 point for the equation. All right, so here we go. So again, you just did 2 minus 3/4 gave you 5/4, and then you plugged in 16. Which 16 to the 5/4? Anybody know what 16 to the 5/4 is?
16 and 5/4.
In a case that another number were there like 3, you divide 6 by 3 and put the.
You would put a 2 there, yeah.
No.
What he's asking is basically if there were a 3 right there, you would do 6 divided by 3 and this would become a 2. That's what he's asking. But yeah. Huh? No, when he comes back. Yeah. Y'all can give him a little bit of rest when he comes back. All right, here we go. What's up? You want to try C? Yeah. Go for it. Try C. Let's do C real quick.
Whoever suggested that.
We got a lot of time.
Your mom's
That's.
See, I got that. Like, I got that.
No, bro.
Did you get this far?
Yeah.
Okay, I can live with that. All right, the rest of this you can just shove in a calculator. I understand, but what's anybody know what 6 times 2048 is?
Mr. Hunter.
I'm gonna like y'all have a calculator. I don't.
I know that, right?
It's probably 12,000 something. 1220. Okay, there we go. 1, 2, 2, 8, 8. 12,288. Thank you. All right.
Now I'll get some water.
1, 2, 2, 2.
All right. Next problem. Turn the page. This one, everyone goes, "Oh my gosh."
A word problem? No.
Nah. All right, guys, these are easy. All right, so here we go. For a white rhino, heart rate, R beat per minute, so R equals heartbeats. And lifespan in S minutes, so that's S is lifespan. And related to body mass in kilograms. Okay, so M is body mass of the rhinos, African rhinos. All right, so here we go. So by the functions, R of M is that, and S of M is that. Find RS of M. Okay, so what is it telling you to do to those two? Multiply them. So here we go. We got 2, 4. Oh wow, I gotta zoom in for this. 241 times M to the negative 0.25. Come on, there we go. Times 6. Is it times 10 to the 6th?
Yeah.
Times M to the 0.2. Is that it?
Yep.
Okay. All right. So start multiplying. What is 241 times 6?
Oh, I know that.
A big number.
I know you know that. Pull it out.
Oh my God.
Wait, where can I say it? It is 1,446.
1,446
Yeah.
times 10 to the 6th. That's the nice thing about scientific notation is I can just multiply it and the 10 to the 6 comes along with it. All right, so your M's, if I'm multiplying the M's, what do I do to their exponents?
And
You add them. So what's negative 0.25 plus 0.2?
145?
Nope.
Negative point
Oh, what?
0.05.
Yes.
Negative
Negative 0.05. So that
Alright.
is the function they were asking you for.
That's it?
All right. So then, honestly, that's what these word problems do. They give you a couple of equations. And they say, hey, add them, subtract them, multiply, whatever. Now, the fun part is this.
Explain it.
Explain what it represents.
Who's doing that?
I knew you'd laugh. All right, so here we go. They multiplied R times S. Well, R is what? Heartbeats. Heartbeats actually in a minute. S is the lifespan in minutes. So if I've got this many heartbeats a minute and I multiply it by this many minutes in the life of a rhino, what is it going to tell you? Heartbeats in a lifetime. It's kind of like saying if I gave 4 French fries to everybody in the room and there are 15 people in the room, if I multiply those together, it's how many French fries are in the room. Well, if it's this many heartbeats in a minute, that many minutes in the life, it is the number of heartbeats in a rhino's life, which is actually kind of a morbid thought. It's like you have 437 million heartbeats left to go, Rhino. What? That's what it is.
Mr. Hunter, I have a question.
All right, we're calling it. That'll be good.